In this video, we're going to be going over relations and functions, testing different relationships to see if they are a function using a series of different tests, such as the vertical line test. This is an extremely common short response question on the IB paper 1, whereby usually it's up to like 1 or 2 marks, which you should be getting. And so let's get into it. So the first thing that we need to know is what is a relation. Well, a relation between two variables between two variables, for example, x and y, and y, is any set of points in the plane of the two variables, and we say that the points connect the two variables. Basically, this is basically saying an equation where a relation is often expressed in the form of an equation connecting variables. So let's, for example, have a different equation. So typically you'll see an equation in the form of y is equal to mx plus c. This is an example of a relation where it's connecting two variables, and the plane in question that's being described in this definition would be the xy plane. This basically just means it has to be encapsulated within this area here. Like the points from the graph show the relationship between the two variables on the plane. That's why it's called a relation. It's typically, you can really substitute the word relation with equation, because that's typically the format you're going to be seeing a relationship in the form of. So, for example, if we have, let's just say y is equal to x plus 3, or x is equal to y squared, these two equations are relations, where each equation generates a set of ordered pairs which we can graph. So basically, inputting different values would give us corresponding values. So say in this equation we look at where x is equal to 2. Well, we can just say y is equal to 2 plus 3 for y is equal to 5 at x is equal to 2. So this is a relationship between the two, because the y is depending on the x and the value that x takes. However, we have to test if the relations are functions. And how do we do this? Using the vertical line test. So basically, the vertical line test is where we draw vertical lines over the function. Now here's the important part. The relation is only a function if all vertical lines drawn touch the function, the graph more, because we haven't actually defined it as a function yet. The graph of the relation at most once, and therefore a relation is not a function if at least one line touches the graph more than once. So basically, the relation will only be a function if all vertical lines only touch the graph once. Okay, it can be less than one, but it cannot be greater than one. Therefore, a relation is not a function if at least one line touches the graph more than once. So it doesn't matter if 1, 3, or 4 lines touch the graph. There's no. It only has to be one, and then it will fail, and therefore it's not a function. So let's have an example. So let's suppose we have this function here. Let's draw the graph of this relation. Um, how do we do the vertical line test for this? Well, we'll just do what it says. We'll just draw vertical lines across the function. You want to make sure it does the majority of the function. However, here we can see clearly that it's only going to touch once. Therefore, we don't need to be too excessive, but we need to make sure it's covering the majority of the function. So here we can see that each line is only touching them once. None of them are touching them more than one. Therefore, this is a function. So a relation is a function. Let's try another one. Let's say we have like a cubic, for example. There we go. Okay. Now let's do the vertical line test for this. Like, okay. Here we can see that it's only touching each part of the graph once. Therefore, a valid function. However, what if we have this graph here? Here we can see it's touching them more than once, therefore not a function. I think typically it'll be relatively obvious whether it's going to pass or fail the vertical line test. So yeah, you can typically do these through inspection, but you do have to show that you are doing or conducting some sort of test to actually test for the validity of the function. So in this case, we would state not a function. Now here's some graphical notation in functions that you will see and you should become accustomed to. So let's say if a graph contains a small open circle, so something that looks like this, the point will not be included, is not included in the graph. But if the graph contains a small filled in circle, like this, then the point included. Now, if the graph contains an arrowhead at the end, so let's say it's something like this, then the graph continues indefinitely. Indefinitely in that general direction. Well, you would have seen this once you've done like quadratics or exponentials, cubics even. You would have seen this arrowhead, for example. Let's just draw a graph. You see something like that typically, meaning that it's just continuing, or even in linear relations, you'll see it, something like that. But also, it means that it's going in that general direction, but it can also mean that the shape can repeat, but or the shape may repeat. So this is something like you've seen in trigonometric functions, maybe like sine and cos, they're indefinitely repeating. All right, another way to test for the validity of a function, which isn't a geometric method, it's more like a bunch of rules, is um, these different subheadings of functions. So let's just, I'll write them out and then I'll explain what each one is. 1 to 1. Then we have many to 1. 1 to many. These are what we call mappings of functions, and they also are able to check for the validity, as some will not produce a valid function. For example, so 1 to 1, they produce a valid function. Many to 1, they also produce a valid function. However, 1 to many do not, and so do many to many. So what do these mean respectively? So 1 to 1 just means that one x value, so one x value has one y value. Now many to 1 means that more than one x value has the same y value. Alright, 1 to many, so one x value has several y values. And many to many is where several x values have several y values. Where many to many and one to many are not functions, one to one are functions, and so are many to one. Well, why? Well, one to many, it will fail the vertical line test. So let's say, for example, we have one x value, let's say you have 3, and it can have multiple y values, let's say it's like a bunch here. What would happen? Well, now if we conduct the vertical line test, it just fails like that. Now let's look at many to many functions. What would happen? So several x values can have several y values. So what would this look like? So let's just say we have a column of x and a column of y. So we have x values and y values. Let's say we have 1, 2, 3. Let's say that y could be like A, B, C, or D. So the one has a y value A, as y value B, and the 2 can have y value A as well as y value D. And let's just say 3 is having value C and value B. What would this look like? Let's say A is here, B, C, D. We have 1, 2, 3. So 1 is matched up with A. 1 is also matched up with B. And 2 is with A. 2 is with D as well. 3 is with B. And also with D. And as we can see, that this replication relationship results in a duplication of many of the primary key. So there's errors in the relationship. So what we can see here is that it won't pass the vertical line test. Why? Well, because look, if you do that, what happens? As we can see, like obviously these points are, just imagine these points are connecting. Well, this vertical line will intercept both points here, this one here as well, therefore failing the vertical line test. So it's important to see if you do get just a bunch of coordinates that you can simply just conduct the vertical line test, or if you can remember these definitions, that'd be great, and then you can just do it via inspection. So yeah, let's look at some examples Alright, the examples are going to sequentially get harder. I'm going to start off quite basic, where you can just apply these different rules and different subheadings of functions, so you won't actually have to conduct any tests. So let's say we have coordinates. Let's say 1, 3, we have 2, 3, 3, 1, and 4, 2. Alright, and let's just say if we are having to decipher whether this is a function or not. Well, what would this look like? So this would be a function because why? Well, this is a function. It is a function. Why? Because for every value of x, there is a y value. And what would this mean? That it is 1 to 1. It is a 1-to-1 mapping. There we go. And if you look here, one x value has a corresponding y value, and here as well. Then if you want to look through them, you can check each one. It's okay, it's completely fine to check. So many to many, several x values have several y values. One x value has several y values. Then many to one, I mean, more than one x value has the same y value. And 1-to-1, one x value has one y value. So now let's look at another example. Let's say we have coordinates 2, 1, 3, 1, minus 1, 2, and 2, 0. Alright, so would this be a function or not? I'll give you guys a couple of seconds to do it. Okay, so this is not a function. Where specifically x is equal to 2 and y is equal to 1 or 0. Why? Well, because at x is equal to 2, the x value 2 has two y values, as y value 1 and 0 simultaneously. Whereby we only have one relationship, so x cannot possibly be 1 and 0 at the same time, therefore not being a valid function. And if you scroll back up, we can see that this is a one-to-many, and therefore not a function. Alright, let's look at an algebraic method, using algebraic methods to decide whether relations are functions. So let's say we have this equation here, x squared minus 9 is equal to x squared minus 9. So why is this valid or not? Well, yes, it would be. Why? Because for every x value, there is at most one value of y. Well, we can test this. If you just input a number into the system, let's just say 1. So y is equal to 1 squared minus 9. Y is equal to 1 minus 9. Y is equal to negative 8. So you can see that it will only output one variable. Now let's look at another equation. Let's look at x plus y is equal to 9. This will also be a function, as for any value of x, x could be any number, and it will still produce one value for y, because it's a linear equation. So for any value of x, Guys, don't be afraid to sketch these out and conduct the vertical line test, or just start inputting random numbers, and then you will start to see that only one outcome or value of y is obtained. So let's look at a different example. Let's say x squared plus y squared is equal to 9. Well, we can manipulate this and show that if x squared plus y squared is equal to 9, then y squared is equal to 9 minus x squared, and then therefore y is equal to the square root of 9 minus x squared plus or minus y squared. This is therefore not a function. Yeah, I don't know if you guys remember, but when you're square rooting any number, it has also a positive and a negative version. For example, square root 4, 2 squared, and negative 2 squared both lead to 4. Therefore, there's always a positive and a negative square when square rooting. So therefore, it's invalid because there's multiple y values for only one x value. Now let's look at examples of conducting the vertical line test. So let's say we're asked to use a vertical line test to determine the validity of these functions. So let's say we have this function here. Well, how would we do this? Well, we would construct vertical lines going down and through the function, and then we can see that it's only intersecting once, at most once, therefore a function. Now let's look at like a circle, for example. If we do vertical lines going through this, I think it's quite obvious to see that if you look here, not here, that's intersecting the axis, my bad. Let's look if you look here, it's intersecting multiple times, twice to be exact, and therefore not a function. Let's look at another one. If we look at this one here, this is an example function graph notation. This means indefinitely or infinitely. On in general direction. Right, so conducting the vertical line test again, we can see that it cuts the graph at most once, therefore a function. Now, let's look at a different type of example. Alright, so let's say that we have a graph of curves y is equal to x squared and y squared is equal to x. What would this look like? Let me draw this out for you guys. I just imagine that this is at the origin. Origin that touches the origin, and then this is y is equal to x squared. Y squared is equal to x here. So let's say we're asked to discuss the similarities and differences between the curves, including whether each curve is a function. You may also consider what transformations map one curve onto the other. So how do we answer this? So y squared equal to x is a relation, not a function. How do we know this? Well, just by looking at it, you can see it's going to fail the vertical line test. but if we do conduct it like so, we can see it fails at multiple points, having multiple intersections. I mean. So um, back. Wait a second. Um, yeah, you can also use these as well, but I think in this case, when it's graphed out for you, it's much easier just to conduct the vertical line test instead of inputting different values and trying to see for what values it is invalid for. So, not a function. However, y is equal to x squared is a function and a relation. So let's see if so when we conduct the vertical line test on the graph of y is equal to x squared, we achieve this. See, it only intercepts once. I know it might be confusing with the other graph here, but I think it is quite obvious that when we have a graph of y is equal to x squared, it's only going to intersect once like that. So we can say that this is a valid function and also a relation. Alright, now let's move on to the next part of this question. So let's say using y squared is equal to x, we can write y is equal to plus or minus x. What part of y squared is equal to x corresponds to y is equal to the square root of x? So what does it actually mean? So the part of y squared is equal to x that corresponds to y is equal to the square root of x is where? So let's draw out y squared is equal to x squared first. So we're trying to find this part of y squared is equal to x that corresponds to y is equal to root x. Well, how can we do this? Well, we can just substitute values of x into y is equal to square root of x. So how can we do this? Well, what we can do is, let's just say we substitute the number 4 in. And we know that the square root of 4 is just plus or minus 2. Therefore, we know that it will be in the first quadrant here. So where x is, for example, 4, y will be able to root 4, which is just 2. So it will be in the first quadrant. Now, what you can do as well is assume that it's positive. So we can interpret this in different ways. So we can slot different values of x into the equation and see what y value we get, and then that will determine what quadrant it will be in. This being the first, second, third, and fourth. Now, what would this mean? So that means that the part of y equals root x is this part of y is equal to y squared is equal to x. So this part is y is equal to root x, whereby the entirety would be y squared is equal to x. Now, let's say we have another part. So is y equals root x a function, and explain your answer. So how can we test if y equals root x is a function? Well, vertical line test again. Only intercepts at one point at most, therefore a function. So to summarize, basically what you want to be doing is to conducting the vertical line test, and then if it is asking you to relate two different functions and finding the different quadrants, is to just start substituting values and seeing what you achieve. Whereby with this y is equal to root x question, I knew that x has to be positive, right? As it's been square rooted, as the root of a negative number lead to an imaginary number, which would be undefined in these circumstances where we're only working on the xy plane. Therefore, by substituting in a number into this equation, I was able to easily see which quadrant it will be in by seeing the y value, of course. So therefore, we were able to achieve the value of y is equal to square root of x. Alright, let's try another example. Let's see that we have graphs y is equal to x cubed and y cubed is equal to x. What would this look like? Y is equal to x cubed is something that looks like this. Like that. And y cubed is equal to x looks like this. Alright. Now we can be asked to explain why both of these curves are functions. Well, vertical line test on both. Excuse me. And then if you do it for this one here, you can see both pass vertical line test. You can also write them on different, or draw them rather, on different axes, so they're separated, but yeah, I suppose that might make it easier to tell which one's which. Alright, and a part B to this question would be like, for the curve y cubed is equal to x, write y as a function of x. So for the curve y cubed is equal to x, write y as a function of x. What would this look like? Well, what this basically means is writing y cubed as y as a function of x. So it's just making y the subject. So y cubed is equal to x means this y is equal to the cube root of x, and there, that's your answer. Alright, thank you guys for watching. That'll be it for this video. Bye.